Okay, good morning. So now we will try to solve a rational inequality. To solve for a rational inequality, so we are going to transform this inequality where the right side is 0. So to do that, we'll change this to 1 over x minus 2 minus 1/3 lesser than 0. Now we are going to combine this expression here as 1, and we know that the LCD for this is 3 times x minus 2. So thus we can transform this inequality into 3 minus x minus 2 over 3 times x minus 2 lesser than 0. Okay, then this inequality, if we simplify this, we can have the numerator, we can have 5 minus x over 3 times x minus 2 lesser than 0. Okay, to make this lesser than 0, there are only two possibilities, no? Either we say lesser than 0, we have a negative numbers. So there are two possibilities. We have numerator is negative and denominator is positive, or we can have numerator is positive and denominator is negative. So we will do case 1. So case 1 is we have a negative over positive. So that is, if that is negative, so we can say 5 minus x is lesser than, it's lesser than 0, and 3 times x minus 2 is greater than 0. So let's try to solve these two inequalities. So we have 5 minus x. Okay, 5 minus x lesser than 0. So therefore we can have 5 is lesser than x, or we can say x is greater than 5. So if we draw that in the number line, so if we draw this one in the number line, we can say 0. Let's say this is 5 here, so around that point 5 is not included. Okay, and if we have this one, we have 3 times x minus 2 is greater than 0. So that would also mean that x minus 2 is greater than 0. So we have x is greater than 2. So if x is greater than 2, let's say 2 is around here, so it's open, no? So we can have this line there, and that would be that side. So what is now the intersection? The intersection is this part to that part, no? So that would mean for the case 1, our solution is x is greater than 5. For case 1, our x is greater than 5. Now let's do for case 2. For case 2, we have positive over a negative. Positive over negative. So that is, we can say 5 minus x is greater than 0, and 3 times x minus 2 is lesser than 0. So let us solve that inequality. So if we solve that inequality, we will have 5 minus x is greater than 0. We have 5 is greater than x, so x is lesser than 5. So we have x is lesser than 5. Then the next one, we have 3 times x minus 2 lesser than 0, so that would mean x minus 2 is lesser than 0. So x is lesser than 2. So the first one, say 0, 2, 5. The first one is lesser than 5. So this is the case. We just do parentheses because it's not included, no? If it's included, we will do bracket. No. Okay. Then x is lesser than 2, so it is in this part. And we have all of this. So the intersection is this part. So we can say, so that the intersection is this part. So therefore solution for case 2, we have x is lesser than 2. So therefore, combining those two solutions for case 1 and 2, we can have solution set is the set of x where x is lesser than 2 or x is greater than 5. Okay, or you can write it in this manner. So we can write that in this manner. So we can have, or this could be solution set. You can write from negative infinity to 2. It's open, no? So it's parenthesis. We have a union 5 to positive infinity. Okay, so we can write our answers in this, either this one or that one. And that's how we solve rational inequalities.